Welcome back to LeetCode Daily Grind. Today is July 3rd, and the question today is minimum difference between largest and smaller value in 3move. So you're given an integer array nums. In one move, you can choose one element of nums and change it to any value, and then return the minimum difference between the largest and smaller values after performing at most 3 moves. Right. So what we can see here is, let's say we have 5, 3, 2, 4, means we can change everything to 3, change the non-3 to be 3, or we can change anything here to be 5. So the largest and the smallest will be different, therefore we return 0. And then we can look at example 3. Let's say since we only have 3 elements, we can set all to be 0 and then return 0. Example 2, we can change, let's say 5 to be 0, 10 to be 0, and 14 to be 0. So the minimum will be 1 minus 0 and become 1. It's kind of hard to understand the problem statement this way and try to think of solution. So I will explain it in a slideshow. So my approach is sorting plus greedy. So first step, we'll just sort whatever input we have. And then we can think about different scenario that we can have when we try to do things in 3move. Instead of saying you're modifying, you can treat it as removing that array. So I can think of 4 scenarios that you can do in greedy. So first one is we remove all 3 largest one, then compare the 4th largest with the smallest. So in this case, you get 1. And then the second one is we remove the 1 smallest and 2 largest. So the difference here is we slightly remove this 3, and now we get this back and then get from the left, block it. So we block from the left, and then we want 5, and then we block from the left again, and then we block all 3 smallest in this case. With an array of length 5, it's hard to tell. So I'm giving you another example. So this is a random array. I have a second row indicating the index from the left, and then the last row indicating the index from the right. So first step, we want to sort it. So now it's in the sorted order. And then next step, we can use the scenario one, which we remove the third 3, we remove 3 largest one. And then now we have the 4th largest one, which you know to access by index -4. And then you can minus the smallest one in this case, and then get the difference is 9. And then we can move it to the right? So now we remove one smallest, the smallest one, and then we remove 2 largest one. In this case, we can use the array at index -3 to minus the index at the value at index 1 to find the difference, which is also 9. And then we move on. In this case, we know that we can always access the value, which is negative in Python. And then we can minus the smallest one in this case after removing 2 smallest. And then the last case, and then we can do this. All right. So after explaining the steps, we can come to solving this question. So we find a pattern where if the length of it is less than or equal to 4, we know you can always make the output to be 0. So we can say if the length of nums less than or equals 4, we can return 0. And as we said, we want step 1 to be sorting. So we can sort the array. Next, we initialize a minimum to be for the infinity. So this means this is equivalent to integer dot max value. I think this should be integer in Java. And then we can set right to be -4 because we want to start with right which at index at -4. And then we can start for left in range 4. So this means left will go from, so left goes from index 0 to 3, which we can see 0 and then 1, 2, 3, right? So here we can set difference to be nums of right minus nums of left. And then we can set the minimum to be equals to the mean or the minimum or the diff. At the end, we plus equals 1 for the right to go from -4 to -3. And then at the end, we'll just return minimum. So we try run this. Let's see it passes the test cases, and then let's see how it performs when we submit it. 266 milliseconds with 86.32%. Not bad. Alright, the time complexity will be of n log n because we're doing the sorting, and the space complexity since we're not using additional space, but the sorting in Python will take a lot of space complexity of n log n. Alright, thanks for watching the video today. I hope you learned something new, and we'll see you tomorrow.